So we will continue with this example of the lone divider method for 3 players. And this one states it's similar to the previous one. It says 3 friends, Mo, Larry, and Curly, are dividing up a set of assets S into 3 shares. The shares are labeled S sub 1, S sub 2, and S sub 3. The table shows how each friend values the individual shares. Determine a fair division of the assets S for the friends using the lone divider method for 3 players. So here's the table here, and we can see from the table that Curly, again, he's the divider, and we could tell that because he divides each share equally, and in this case 33 1/3%. So then we're going to go through here for Mo and see which share that he labels as a fair share. And of course the only one that he labels a fair share is share 2 right here. Don't forget a fair share is any player expects to get at least 33 1/3%. And the only one that seems fair to Mo is share 2. And Larry, we look for fair shares for Larry, and the only one that he designates as a fair share is also share 2. So since they both value only share 2 as a fair share, we have what is known as a conflict. We can't determine who gets which share according to this table because they're both demanding the same share. So the first thing we do is award one of the remaining shares to Curly, the divider. Now, typically the divider goes last and gets whatever share is left over. But because we have this conflict, we award a share to the divider first. Now to Curly, since he is the divider, it doesn't matter to him which share he gets because he values them all the same. However, whichever share Curly gets can affect an optimal decision for the remaining players. So to keep everything fair, Curly is awarded one of the remaining shares randomly, and this can simply be done by flipping a coin or some other random method. So suppose a coin is flipped and Curly gets share 1. I'm just going to circle it like this. So since he gets share 1, I'm just going to draw a line through here to show that share 1 has already been taken and that Curly has already been awarded his share. We then now recombine the remaining assets of the remaining players. And to do that, we simply add up the values of the remaining shares. So to Mo, share 2 is worth 50% and share 3 is worth 26%. We're going to recombine them, 50% and 26%, and we simply add, that's 76%. We do the same for Larry, the other player. 62% and 20%, we simply add them, and that's 82%. This is known as recombining the shares. Now from here, we then utilize the divider-chooser method we learned in the previous section. I'm just going to write it up here. Divider-chooser. So now one of the remaining players becomes the divider and the other one becomes the chooser. And if you recall from the previous section, the divider could only guarantee themselves 1/2 of the asset. The chooser, on the other hand, is guaranteed at least 1/2 of the asset. So it's always better to be the chooser than the divider. So because of this, the divider is determined randomly. And again, this can be done simply with a coin flip. So suppose Mo wins the coin flip or loses the coin flip, depending upon how you look at it, and Mo becomes the divider. Then Mo can guarantee himself 1/2 of the recombined asset, and 1/2 of 76% is 38%. Since he's the divider, he can guarantee himself 38%. Since Larry would be the chooser, Larry would get at least 38%. If we flip a coin and Larry becomes the divider, it's the same thing. Larry can guarantee himself 1/2 of the recombined asset, and 1/2 of 82% is 41%. He's the divider, he's guaranteed 41%. Mo would be the chooser, and Mo will get at least 41%. But either way, Mo and Larry will get at least 1/3 of the original value, 33 1/3% of the original value that we started with. So everything seems to work out. We could even do that if we flip a coin, and instead of Curly being being awarded the first share, let's suppose he is awarded the third share. So he gets share 3. And I just like to go ahead and cross out share 3 since it's already been awarded, and Curly has already gotten that share. Again, the remaining assets are recombined, and then we utilize the divider-chooser method. So we'll do that. 24% plus 50%, that's 74%. 18% and 62%, that's 80%. We flip a coin. Mo winds up being the divider. He is guaranteed at least half of the recombined asset here. That's 37%. Larry, being the chooser, is guaranteed at least 37%. If we flip a coin and Larry becomes the divider, he is guaranteed at least half of the recombined asset. So that's 40%. Mo becomes the chooser. Mo is guaranteed at least 40%. And again, either way, Mo and Larry will get at least 1/3 of the original value of the asset from where we started. And there we go.